Last class we talked about the formation of the three different types of rocks and how each of those types of rocks can be changed into another form to become another type of rock in the movement throughout the rock cycle. What we're going to talk about today is how those rocks then get broken down to eventually become what we know as soil. How the rocks get broken down is through a process called weathering, and weathering can be done two different ways. The first is mechanical weathering, which is actually physically breaking down the rock into smaller pieces, and then chemical weathering is changing the mineral composition of the rock to deteriorate it and break it down. Mechanical weathering is done by physical forces, and they break the rock into smaller pieces, increasing the surface area, which then in turn increases the rate of weathering. The more surface area there is on a rock, the faster it can be weathered, because of the fact that it is more open to all of the elements. The most common type of mechanical weathering is frost wedging. Frost wedging is when a rock has a crack in it and then the water gets inside that crack. We all know that if we put water in an ice cube tray, we stick it in our freezer, what happens to that water when it freezes? It expands and makes larger ice cubes than the amount of water we initially put in. Same thing holds true with frost wedging. What happens is, and you can see in the diagram here, that water fills the crack. That water then freezes and expands, breaking the crack and making it larger, eventually to the point where it's going to break off the rock and create an entirely separate piece. Unloading and exfoliation happens when igneous rocks make their way up to Earth's surface. When they get to Earth's surface, there is less pressure on the rock layer than it initially had below Earth's surface because it's now exposed. And because it's exposed, that pressure, or the igneous rock, can then expand slightly. When it expands, since rock is not a pliable thing, the rock breaks off into pieces, and you can see here in the image that it breaks off into these sheet-like pieces that just slide down the hill. The third process of mechanical weathering is biological activity. So any activity from a living organisms like plants rooting themselves into rock layers, animals burrowing tunnels to make their homes, and also humans just plowing up the land or cultivating it for our crops. All of those activities are going to cause the rock layers to break apart into smaller pieces, which then can be eroded away, eventually coming sedimentary rocks. Chemical weathering, like I said, transitions the rock from what it initially was into one or more new compounds. The number one chemical agent in chemical weathering is water, and mainly water as in the gaseous state. What happens is the water reacts with other minerals to then do one of various things. So oxygen reacts with iron to then form what we know as rust. If CO2 in the atmosphere interacts with groundwater or water as it rains, it's going to form carbonic acid, and the same thing with sulfur and nitrogen. It's going to create sulfur and nitrogen or nitrous oxides, giving us acid rain. That acid, as in the form of rain, or if the groundwater interacts with them, will then start breaking apart and eating at all of these rock layers. The things that affect the rate of weathering, the biggest is going to be the climate when it comes to chemical weathering. Chemical weathering, since you need water for chemical weathering, it's going to happen much more rapidly in a warm, humid climate. So the moisture in the air allows it to react with other elements to then start breaking down the rock. Also, the characteristics of the rock. Are there a lot of cracks on the rock? Does it have a lot of jagged edges? If it's got a lot of jagged edges and surface area, it's going to be broken down much faster than something that is already smooth and rounded. Also, the variation in mineral composition. If it is formed by something that has a lot of calcite in it, it's going to be very soft and it can be broken down a lot easier than, say, an an igneous rock that has a lot of quartz inside of it. Quartz is a much harder mineral than calcite is.